Welcome back, learners. And as we have said before, first concept, and that is going to be the heating effect of electrical current. So remember our main idea, we're going to be looking at the effects of electric current, and we are starting with the heating effect. So let's begin. We should know that an electric current is the movement of charge in a closed conducting circuit. An electric current can generate heat in a resistor. So the electric current that you're talking about can generate heat in a resistor. Remember that this is a device that allows current to pass through but does not make it easier for the current to pass through. So as electrons move through a resistor, they encounter resistance because that's it not wanting or not making it easier for the current to pass through or for the electrons to pass through. So as these electrons are moving through a resistor, they encounter that resistance given by the resistor. And as they're encountering that resistance, they transfer some of their energy to the resistor itself. Remember, the energy in question here, or the energy that you're talking about here, it is that energy supplied by the battery into the electric circuit. Because as the battery supplies energy into the electric circuit, the electrons within the wires of that electric circuit will receive the energy and start moving. And as they are moving in one direction, they will now have both the potential energy and the kinetic energy. So as they're encountering the resistance within the resistor, they're going to transfer some of their energy to the resistor itself. Now, an electric current can cause objects to increase their heat. Because this energy that is being transferred into the resistor, it can be transferred in a form of heat. And because of that now, that electric current can cause objects to increase their heat. Why? Because they have transferred that energy in a form of heat. Furthermore, the heating effect of an electric current can be dangerous. So as now those electrons are transferring their energy into the resistor itself, that heating effect of the electric current can be dangerous. What do we mean by that, and what happens? So if a circuit overheats, it can cause a fire. So if a circuit overheats because now there's more heat built up, then that can cause a fire. So to avoid all of that, we're going to be using something called a fuse. So to avoid overheating, circuits often contain a fuse. So a picture of a fuse is given here on the side, and the symbol for a fuse is also given on the side here. So now, fuses, they contain a low resistance. So basically, these are also resistors. So a fuse is also a resistor. However, they contain low resistance. Remember, if resistance is low, then current is going to be high. Why? Because those two devices have that particular relationship that when one goes down, when a resistance goes down, the current needs to go up. So fuses contain a low resistance wire made of a metal with a low melting point. Therefore, the piece of wire melts if it becomes too hot. So remember, as the battery supplies energy into the circuit, the electrons receive that energy and start moving in one direction from one terminal to the other terminal. So now as those electrons are going to pass through a resistor, they're going to encounter some resistance, and when that happens, the electrons are going to transfer some of their energy into the resistor. And that resistor will receive that energy, and then therefore it can overheat. And to avoid this, because we know that overheating is very dangerous because it can cause fire. So to avoid all of that, that's the reason why we have a fuse in all the electric circuits that we have. So before going on to our next concept, let's quickly go for a short break, and I will see you just after this.